Hello everyone. In this video, we're going to be looking at Pythagoras' theorem. I'm just going to write the theorem at the top of the page, which is a squared plus b squared equals c squared. Now, let's take a look at the first one. This is a and this is b, so let's square the numbers. 5 squared equals 25. And 4 squared equals 16. And remember, squaring is just multiplying the number by itself. Now we'll add them. 25 plus 16 equals 41. Now we have to do the opposite of squaring for c and square root 41. And the square root of 41 is 6.4, so we'll write that on. Let's take a look at the second one. We have a and b, so we'll square the numbers. 6 squared is 36, and 12 squared is 144. 36 plus 144 equals 180. And the square root of 180 is 13.4. Now, with this triangle, we have A and C, but we don't have B. If the theorem to find c is a squared plus b squared equals c squared, this means that we'll have to do c squared minus a squared, and that will equal b squared. So, 4 squared equals 16, and 8 squared equals 64. Now we'll do 64 minus 16. Because we're doing c squared minus a squared. And 64 minus 16 equals 48. Now, we have 48, and now, when we square root 48, this will give us the length of b. And the square root of 48 is 6.9. So, b is 6.9. Now, let's look at this last one. Here, we have b and c, but we don't have a. So this time we have to do c squared minus b squared, and this will give us a squared. 14 squared equals 196, and 12 squared equals 144. Now, we'll do 196 minus 144. And that equals 52. Now we'll find the square root of 52. And this is 7.2. So A is 7.2. Let's look at one final tricky problem. This one has 3 right-angled triangles and 1 equilateral triangle. Now, these measurements have x in it. And here we have the triangle that has x, so let's figure out what x equals. Since we know this is an equilateral because of these markings, if this side is 5, this side is also 5, meaning that x equals 5. Now that we know x equals 5, this side is the same, so we can write 5 in here. Now, let's figure out the other x problems. 5 plus 3 equals 8, so we can write that in. 5 plus 1 equals 6, and 2x, which is just 2 times x, and 2x, which is 2 times 5, is 10. Now that we have 2 measurements in these triangles, we can figure out the rest of the measurements. Let's start with this one. And since we already have the hypotenuse length, we have to do c squared minus b squared, and that will give us a squared. 5 squared equals 25, and 8 squared equals 64. 64 minus 25 equals 39. And the square root of 39 equals 6.25. So we can write that in. And this side will be the same as this one, so we can write that in on this triangle. Now let's do reverse Pythagoras for this triangle as well. We'll do c squared, which is 10, minus a squared, which is 6, and that will give us b squared. 10 squared equals 100, and 6 squared equals 36. 100 plus 36 equals 136. And the square root of 136 equals 11.66. So we can write that in here. And this side will be the same length as this triangle. Now that we have two lengths in this triangle, we can do normal Pythagoras and do a squared plus b squared, and this will give us c squared. 6.25 squared equals 39. And 11.66 squared equals 136. 136 plus 39 equals 175. And the square root of 175 equals 13.22. So we now know that the length of this side is 13.22. And with just one number and a few x problems, we figured out the lengths of all of these triangles. I hope you enjoyed this video. Let me know what you think in the comments. If there's any more Pythagoras explanation that you'd like me to do, let me know. 25 plus and with just one number and a couple x problems, we figured out the lengths of all the